Sorry. Good morning, one and all, and welcome back to the second session of today. It's a great honor for me to introduce you all to our eminent speaker for this session, Dr. D.K. Shinde, who will be taking this session on 3D printing of polymeric non-composite prospects and challenge. He is an associate professor and the head of production engineering at Viramata Jizabai Technological Institute, Vijaytia, Mumbai. He has a vast experience of 19 years in the industrial production engineering academia. His research field includes process modeling in composite nano-engineered materials and nanotechnology, electrospinning molecular dynamic simulation for polymeric composite materials, multifunctional materials low-cost composite manufacturing, mechanical characterization of materials, computer-aided design, finite element modeling fatigue, impact modeling, and testing of polymeric composites. He has received various awards which include the Best Startup Award by World Trade Center Mumbai and Chamber of Commerce and Industry, Best Dronacharya Award for Mentoring Innovation Product for Smart Navigation Band at National Level Entrepreneur Competition, Dr. Kennedy Scholar Award, North Carolina A&T State University. Over to you, sir.
Yeah, good morning, all of you. Let me share my presentation and then I will take you through today's entire session on 3D printing prospects and challenges. Can you see my screen? Or organizing team and participant, can you give me the feedback?
So screen is visible but not entirely. Maybe you have to share entire screen and then maybe possible.
Can you see full screen?
Yes, sir. Yes, sir. You can see that. Yeah.
Yeah, so once again, I welcome all the participants for the day 3 of this Atal FDP on 3D printing, which is a very important one of the training program launched by the AICT in the thematic area 3D printing. One of the fifth area in which the 3D printing comes in the today's technology development and the manpower development by Atal Faculty Development Program Academy from AICT Delhi. So I welcome all of you for this day 3 session. So before I start my session, first of all, I thanks to Professor Kiran Bhole sir for inviting me as an expert to deliver a talk on 3D printing of the polymeric nanocomposite prospects and challenges. So I thank you, sir. Also, I thanks to the organizing team and the institute, Sardar Patel College of Engineering, Andheri, Mumbai, for giving this opportunity to share my some of the views and the material what we have created through the research at VJT and my past research at North Carolina A&T State University, USA. So let me take you through the quick presentation. If any interruption occurs, let me know either by the call on a telephone or you can ask me by audio also. So that is the first instruction. And second thing is, if you have any question, kindly hold your question. I will take your all the questions at the end of the session, and then I will answer your queries. So meanwhile, the noise and all those things, try to avoid any background noise so that all the audience can listen the session carefully. With this few instruction and announcement, let me take you through the today's presentation. So I will be taking you through this important 5 aspect of 3D printing. First, I will talk about the nanotechnologies, past, present, trend, and growth. Because to understand the nanocomposite, you need to know little bit, or refreshing of the nanotechnology, nanomaterials, and how those nanomaterials we can take in the our material to develop the 3D printed parts and structures whatever we want to develop, and how those nanomaterials are playing an important role. Then few of those published research whatever we have done so far, effect of nano carbon nanotubes and graphene on ABS for the mechanical and electrical characterization, which are developed and produced by using the fuse deposition method for the polymeric material. Then one of my PhD scholar who is submitting his thesis, he is working on the infill patterns, role of the infill patterns, and how infill patterns with the percentage infill with and without carbon nanotubes. Again, in the ABS as a base material, what we have selected, I will be talking on that one. Development of the two remaining two important aspect what I'm going to discuss very decent prospect and challenges what the aerospace and big BAM what we say the big area additive manufacturing, the large scale additive manufacturing for the high strength fiber reinforced composite to develop heavy structures, and what are the challenges, what are the prospects, how it will be helping in the aerospace when it go for the moon mission or maybe for the Mars mission, or maybe international space stations, how our astronauts can use this technology and develop the quicker those parts, and what are the challenges they may face, the early stage uh, continuous fiber 3D printing uh, development from the Lockheed Martin SpaceX aerospace. I will be talking to you. I just one of the published research in the SAMPI 2021. If I get time, I will talk about the nano fiber synthesis and those applications if I get more time. So let me introduce myself. If you are from all over the India, we are located in the central part of Mumbai. This is what we have our Gateway of India, known to in Maharashtra, western side. This is VGT has 17.6 acres of land established in Victoria Jubilee Technological Institute in 1887. Now it has been become the name as a Veer Mataji Jabai Technological Institute. Acronym remains same. In 1999, they renamed the institute. I did the PhD from North Carolina State University from USA. I work in the Joint School of Nanoscience and Nanoengineering, a big center for the Greensboro campus of North Carolina university system. So this is what I want to share something, but I want to just acknowledge my previous research also. So VGTI well known. Just I always talk about my institute also wherever I go for any talk and deliver any talk. So we offer a diploma, UGPG, and PhD program in respective branches. So we have the REI ranking fifth in government colleges in 2020. NRF ranking of the currently published is 82 among the engineering group and technology group for the 2021. 82 is our rank of the institute. I come from the Department of Production Engineering, which is established in 1959, and then subsequently after DIE program. In this department, our department is having UGPG and PhD program in the production engineering. Few of those intakes, 16, UGP established in 73, production in 88, and production engineering 2002, and currently we are running one more program. So that's it about my introduction and my institute. So let me go through you quickly through what is nanotechnology. The man first who gave the idea about there are lots of room at the bottom of the plenty of the room at the bottom. Who gave the first ray to know what is the nanotechnology? The Richard Feynman. He thought initially how we can use that smallest things at the nanoscale, like maybe a few angstroms, 10 angstrom, 15, 100 angstroms of size, and how we can keep playing about that one. So he gave the idea in the 1959, and people reached the in the search of finding such kind of material technology system development. So nothing nanotechnology, if you are new, so it is art of science of building the stuff that does stuff at nanometer scale, like 0 to 100 nanometer scale. We treat as a nano scale synthesis, manipulation, development. So the Richard Samley in 1996 he received the Nobel Prize, and he developed such kind of small device materials at the scale of 100 to 0 to 100 nanoscale. So few of those molecular modeling has been shown over as an engineered DNA strand, RNA, tiny motors, and semiconductor metal junction formed using two carbon nanotubes. So this is so purely, if you want to know what is nanotechnology, is 1 billionth of meters, or you can say 10 to the power minus 9 of meter is equal to 1 nanometer. If a person, how small in size and shape, if you want to think in quickly, if a person can walk in a day, like about 32 kilometers or maybe 20 miles in a day, if you shrink the height of the person, average height is 5.5 inch, you can say 5.6 inch or 5.8 inch is the average height, you can say. If you shrink that 5.5 5 feet 5 inch person to a smallest size, like whatever your 10 rupees bill or maybe a dollar bill, $1 bill is the same size. The smallest, if you make how long that person can walk, the same kind of concepts comes in the mind when you go for the scaling down to know about more about that matter, things what happens at the scaling down. If you shrink the person from 5 feet 5 inches or 6 inches to let's say the 1 inch 3 inch or 2 inch of a person, so how long he can complete that distance is just imagination. So if you see, it will take a 24 hours. Let's say the 3 inch of note size length is a 3 inch. So the same person, if you shrink it or make the smaller size of the same person, so he will take to walk the same distance about 32 kilometers or maybe 20 miles, it will take almost 24 years. That is how the size matters, how small size is playing important role to make those displacement or say, dispersion of that particular particle mix. So this is manipulating. It's the science of manipulating atoms, molecules, make the new materials and devices, and lots of things are coming from science, engineering, technology, which make the interconnect. And few of those which came in the early stage of development of the material, maybe your bucking, came with the buckyball, and then nanotubes came, and then you have the nano ribbons, and those kind of nano ribbons can be now widely been used as a graphene to totally a plain graphene sheet to the formation of different nanomaterials. And if you compare the size of the new, human, which is nanometer 60 to 800, micron size of the person. If you go with the comparison with the smaller size to understand more about how the and which nanomaterials we can use in the 3D printing also. So from the right to left, if you go from the tennis ball, 10 to the power 8 of nanometer, then you have 7 as a 6 as a period, then cancer cell and bacteria and viruses, what we are suffering in the pandemic. COVID pandemic is around 400 microns size that comes in the the funnel of your nanotechnology, where all these materials can be an effective tool to capture such kind of viruses and work with the biological nanomaterial. And then you can go with the lower size, where antibodies is having 10 nanometer. If you go the glucose one molecule size, which is 1 nanometer, and then if you go with the water molecule H2O, which is having point 0.1 nanometer size, like that we have the scale. But there is the molecules and atoms become more stable due to its energy and applied manipulation or stabilization energy. They remains as it is in the range of 0 to 100 nanometers, and therefore people keep developing those material in the same range and above that one, to use it in the conventional material to enhance the mechanical, electrical, or thermal properties for various applications. That's the main idea to understand about the nanomaterial, where I will be talking how those nanomaterial can be helping us to make the 3D composite, nano composite. So few of those scale things are also shown over here, to understand more better and how the 3D printing can develop those kind of using top down approach, or you can use your bottom up approach. Both are used in the nanotechnology, but our 3D printing is a bottom up approach. So layer by layer we keep developing or cutting those particular structure, and we build the entire structure and then provide those connectivity and make such kind of devices, which are shown over here by comparing the natural things available in the nature and things made by the person on the right hand side using the head of the pin or your micro electromechanical DMMs devices, or maybe you can have your pollen grain ray ribbons, and right side here the challenges to develop such kind of molecular models and stabilize the model, which comes blood group and what we made up from the DNA, which comes in a picture over here. So this is comparison how small hair look likes and nanofibers look like at the bottom level. Few of those nanotechnology past and present, which National Initiative for Nanotechnology talk about United States in the early stage. I'm going to share few of those slides. Nano 1, Nano 2 and Nano 3. So 2000 to 2010, it was Nano 1, 2010 to 20, whatever the system material so far been developed is 2. And now we have entered in the era of 2030 era, where we are expecting much more expansion of this technology and integration and augmenting the technology to develop the new devices and materials in the early stage of fabrication using the 3D printing. So molecular printing or maybe drug printing are the various aspects coming in the 2030s era, where 3D printing have the challenges and very high prospect. That's what I'm going to cover in few of those coming class slides over here. So those fundamental and all those, I'm not going to read those things, but what I want to say, where we had at the early stage of 2000, we create the only the material has been developed, few tools has been developed, and then it comes to the assembly of the integrating parts, and then spin off came with the current 20 to 30 era, where we are getting the new nano system materials, and some of those businesses are coming with the 3D printing and developing those materials, structures and devices at your own backyard, or maybe in your own house in the next coming 10 to 50, 20 years. And that is what going to happen, and nanotechnology will be helping. You can print your own drugs, take the mixture, and you can print your own drug, and it will mix in such a proportion and develop your peel, what we say the tablet, maybe in the elliptical form or maybe circular form, and then it will harden it, and then same peel will be available with you. So you just need to fill those drugs in the feelers, and it will be printing your drugs. If you need to your child, you can print the same drug at your home. If you need to your older age people or middle age people, you can print at your home and you can get it. No need to run to immediately to your medicine shop. So that technology can be coming in terms of the 3D printing. So many other things are coming, but I'm not going to talk. So the new product and applications have the big prospect as a revenue generation in the trillions of figures. So therefore people people are continuously working in that area. So few of those inspirations which comes with the national nanotechnology initiatives, which make the people vision inspired basic research, and now onwards the people are moving from the next 30 to 2030 with the convergence of knowledge and technology for the societal development. Few of those breakthroughs which came through the nanotechnology, so those are not important at this perspective, but let me go with these slides, which came with the 2020 Bill Clinton brought that initiative, national nanotechnology initiative, and then it was pushed by the technology pushed by the next president, W. A. Bush, and then subsequently Barack Obama took over, and the technology development in using the nanotechnology was yeah, one of the most. And now after the Trump, the technology has taken a good shape, and currently the Biden is also making more, supporting and expansion of this technology for human and societal development through the nanotechnology. So few of those, one, two, three. So we are at the area. We are at the three technology decades. So here, what the nano system, and these are coming uh, for the discussion in this one. So these are the way how we can develop those, platforms and projects can be coming. So few of the nanotechnology which emerge with the each of those. So I will exclude this one, since we will be having a very less time to talk on that one. So uh, let me take you through the those expansion with the your, particularly in 15s to 2013s, what hierarchically interconnected word is using the nano, that really played in the year of 2020, and now the people are accepting the few of those areas like brain to brain communication, so non-instructive brain to brain construction. Few of those children are suffering from the brain disease, can be one of the way which nanotechnology will be helping them to make. So still these are the developments. So the technology wise, the papers which are coming, so lot of scope to develop the new material using the nanotechnology, and you can immediately have good impact factor and good chances to publish in the high impact factor journal. So this shows the indication of the top countries: US to Japan, European, and China, how it has been grown with the publication record. Similarly, what the materials they are using also, so few of those materials are noted, like technology-wise, names devices, quantum dots, molecular motors, STM, AFM, molecular models, and atom models, and self-assembly. So if you see the self-assembly and STM-TM are helping to make most of the publication and bring the new technology or manipulation of those nano atoms at atomistic level or molecular levels are coming. So in the electronics area also, the quantum dots and quantum wheels are playing important role to miniaturize the technology to develop the 3D printed parts at very nanoscale level. So the material which emerged with the graphene as one of the top material, and its are allotropes. What are the coming with the carbon allotropes in the form of graphene, carbon nanotubes. Then you have the buckyball and other graphene sheets plays an important role. So some of those are been shown with the rising the publication with the starting of 80 to 2020, and those contribution of the journals, again piping, US is going ahead with those journals, so we need to also contribute in publishing such a high impact journals. Worldwide growth is also, it's substantially or exponentially increasing the growth by filing the patent and approval of the patent in the few top countries. And similarly in the nanotechnology area, if you work, you can have better opportunity and to file the patent very immediately for process development, product development, material development. That I can encourage all the participants to work on that, and you have the larger opportunity as a part of Institutional Innovation Council of AICT and the Department of Education of Government of India. They are looking for more patents from the faculty and those ones. So these are the prospective way of having the growth in the coming years of 20 and 20 onwards in terms of the revenue generation of the indicators of the this one. So the material development plays an important role. Therefore, the all the systems and devices what we want to develop using the nanotechnology, it's not like only the manipulators like what STM, AFM, or STM, or maybe your helium ion microscopy. They are not going to build it all those things that but you have a lot of scope to develop the existing or conventional things to make the better performance, and therefore there are the only ways left to use those nanotechnology ingredients whatever we have developed in terms of the nanomaterials, use those materials, and therefore in the 20 and 20 onwards, the nanotechnology is helping us to develop nanosystem by design. That's how our nanomaterial what we print using the 3D printer will be also coming in this area, and therefore I'm discussing all those things to know more about the material growth and prospective way of generating the revenue also over here. So therefore, the world is looking for getting more and more in the form of your materials in each of those area, continuously increasing. So in the 35% growth in the material development, and still it is going to be increased in the coming days. And some of those publications were, those 5 countries is continuously increasing. That is little, introduction about the nanomaterial prospects and technology, introduction of nanotechnology and nanomaterial. Now, how we can use those nanomaterials? So this is a paper published in the 2019 SAMPI international conferences and converted into technical, Scopus publication. So I will be talking on the mechanical electrical properties of the carbon nanotube based ABS. So acrylonitrile, butadiene, styrene, which is what we say the ABS material in the market, and mixture of these two we treat as a nano composite, and how we can improve those properties using the best way to play with the all polymers which are thermoplastic or maybe thermoset polymers. So we can go with the developing those material using the fused deposition modeling method, what we treat as a FDM processes. So those things I will be talking. These are the quickly concepts. So let me overview and explain you the fused deposition modeling. So it's a layer by layer deposition, of material to build the structure according to the what CAD file and model we have developed. So slicing using the converting the STL file, all of you know, and those STL file a thin layer will be taken from your extruders and that printing head. You will be having the, this is the general view to a platform on which you will be having the support material first, and using the dual extruder printers we can connect it. We can have the two spools connected. One is a support material, other is a printing material. So this printing head will be depositing, and its height will be adjusted. So it will X, Y, and Z direction, all three direction, motion of those extruder has been provided. So this FDM, typically, like most of those available, the wire diameter or filament, what we say is 1.75 millimeters in the form of a coil or a spool, which will be passing through this side. In the extruder, the material will be melting, and then we will be depositing and suddenly curing. So curing is very important. Solidifying, or maybe in thermoset we say the curing word. So those things plays an important role for the 3D printing to build the structure. And then few of the techniques like Mark Forge and other guys, what they are developing of Strata, they are developing the new printers of the industrial use. They have the very high quality of materials, what they customize themselves, and they start printing. Nowadays you can print on the surface with the all text material, like let's say you want to print like VJT on the surface with the color only. So the same kind of spool you can provide the material, and you can uh, print it instead of having the painting or maybe stick around that one. So those kind of material developments are in the right now going on in this era, and we have a lot of opportunity to use. Let me just show what are the things people they are just build those structures using 3D printings, maybe starting from your small geometrical shapes, sizes, what we look for to bring in the life, like gears are widely been used, levers, gears, and some of the toys, what we can say. Then construction, you can say the medical industry is a big big scope right now. Few of the people who built the heart, say heart, how we can run that heart. If this material is biocompatible, like what the heart we have, the same material if you develop and give the pulse and keep running this diaphragm going up and down, so the pumping of the heart can come here start. There is a way to develop artificial pump. Only the signal is the only issue. So mostly the functional material, if you have provided and the signal is given through our neurons, and that much volt has been given to the multifunctional material or smart material what we are going to use and print a heart, it will definitely work like your natural heart. But still the many days to go to develop those things. A few of those, like developing the aerospace components, I'm going to take few of those case studies. So if you look this figure, this is a published paper in 2017 from me and my group. We have published the review paper in that one. So this is how we can see the transparent 3D view of the platform. The extruders are coming with those depositing on the uh, your plate, whatever the support plate, what we say the substrate in terms of your deposition. So the electronic circuit and you have the simple frame. Now people are assembling and having their own frame, maybe less than 12,000 or less than 10,000 also right now. So what it does, like process, we have the component. Typically, we have the component like, let's say, the C kind of bracket. So how do you create? So we create the 3D model and then we slice it using the STL file. So stereolithography, those files we convert, and those CAD file we give to the our processor, and then accordingly your M code, G code and M codes are created, and accordingly your X, Y, and Z, those motors will be giving the motion to the your extruder, and motion will be deposit helping us to deposit the layer to print 3D printing like this one. The typical way of looking over the stereolithography is you may be having such kind of simple built platform where the height plays an important role. What is the height of your structure you want to develop? So those layer of deposition and the sweeping of, in the sense what I shown in the previous figure. So the moving left to right, front to back, up and down. So those motions will be coming, and those whatever the lenses are helping to feed the material will be coming over here, and you will be depositing, and using the UV light or maybe laser, you can simply cure it in a short duration of time, and you can make the strong bond with the bottom layer with the deposited molten form of the polymeric material. So this is how the photopolymer can be used to cure using the like UV light. The photolithography, how the positive resistance, positive photolithography or negative photolithography. So photo resistance material get hardened, and accordingly the liquid polymer also have the effect of curing faster using the UV light in that case. So if you look over here, the FDM process, what I'm going to use in my process also to develop my nanomaterials is the similar kind of depositing the material with your substrate. So build platform, then you have the support what we call substrate, and then you keep developing. So these rollers plays and very important to feed the material through this to the extruders. So in these extruders, we would have the heating zones where which will melt, not immediately the in the form of liquid, but molten form it will reach, and those nozzles will be allowing to deposit, but chances to get clogged. So those challenges and taking care of that self cleaning or a certain deposition layer also is a cycle has been operated in the today's printed technology, right? Or develop the new printers like that. So another way the people are developing the laminated object, what we have the fiber laminated composite or fiber reinforced polymeric composites. What we have conventionally, we lay down the our fiber view forms, we stack inside the mold, and then we infuse the resin, and then we build our composite panel or maybe the structure what we have. So that is the way. So but there are lot of tool cost is involved, material waste is involved, as well as the chances to exist some of those voids, and manufacturing cost is very high and productivity is very low. So therefore, there are people who are developing right now the laminated, objects, like what how we can use it. So the roller, complete roll is coming over here, and then you can keep printing or maybe developing a step by step and build the structure also. In this particular image, the laminated object, how it can be manufactured by heated roller, and then you can print it, and then the wasted roller will be coming like this. So this much material can be again go for the recycling, and you can keep using. Again, we pass the laser or UV light, and we can create those mask or transfer those particular object on the uh, substrate like that one. So this is how little bit fuse deposition modeling will be helping. In the simple way, people many times they talk about additive manufacturing or 3D printing, but now the word is moving to understand the simple word with the 3D printing rather than additive manufacturing. But it is a part of the additive manufacturing. So we develop everything using the bottom up approach. So in our lab also we have the 3D printer divided by zero. So this model we have used to develop our material. So what we have done in this one, our spool, and then same customized spool has been used on the 3D printer divided by zero, what I have shown over here, active soft. And then we printed the material to be tested like dogbone kind of shape for the tensile, rectangular for the flexural, and other shapes according to ASTM and ISO standards, to print the material and test it rather than wasting the material, so as to analyze what are the mechanical properties has been built by developing such kind of material with the thickness which what we are interested over here. So styrene ABS is a copolymer made up from the polymerization styrene and acrylonitrile in the presence of polybutadiene, and therefore this material becomes like a rubbery. It has a shiny in shape and impervious surface, and therefore it has a resilience to the low temperatures, and it can act like a one of the improvement in to have the impact resistance, toughness, and heat resistance. Because of these four important property, ABS is widely been accepted in the automobile industry in the dashboard and interior part, and therefore it has been motivated us to do the 3D printing of nano composite and see what property we can improve in this one. So here, what we did, the same method we utilized. So in our experimentation, what we did is we selected the three important weight percentage: point 0.1, point 0.2, point 0.3 weight percentage of multiple carbon nanotube to mix it. So what we did, we have the vendor at Nasik, and solid space technology at Nasik. So this is a rotating mixer. We have the pallets. Generally, all the polymers, manufacturers, they give in the solid pallets, small, maybe like 5 micron or 10 micron length of the small pallets, having the smaller diameters, which can easily melt, and you can create any kind of wire, or you can create any shape and size using the different mold technology. So in our experiment also, we had pallets of the ABS. They were looking like a white in shape. So what we added, that three important weight percentage over here. So point 0.1, point 0.2, and point 0.3. So these three pool we want to manufacture. So we mix with the point 0.1 in weight percentage in the pallets, and using the rotor mixer we disperse the multiple carbon nano tube, which look like a powder, and having the smaller diameter length. My aspect ratio is also low, and that was after mixing it was looking like this one. So the all the surface of the pallets has been occupied or coated with the multiple carbon nanotubes. Now this mixture will be poured in the hoopers of the extruder machine, where it will be melt, and it will pass through the different heating zones and cooling zone, and then at the end, extruder will produce our customized spool. This